So, welcome to the first actual topic in Level 2 Mechanics, vectors. So, in terms of vectors, well, a vector is a value which includes both a direction and a size or magnitude. So, for example, velocity is an example of a vector quantity because it has a direction, say up or down, north or south, and also a size, so 10 meters per second. North or south or up or down. So in terms of vectors, you also have to know the difference between the concepts of distance and displacement. They might seem the same to you, but they are very different in physics. So distance is the basically how far an object has traveled, and displacement is how far an object has traveled from a particular point or in relation to a particular point. To highlight this, let's look at this particular car from the franchise cars. So you can see clearly the difference between distance and displacement. Okay, so distance is going to be the sum of all the individual distances that the object has traveled. So 10 kilometers, 10 kilometers, 15 kilometers, 20 kilometers, and 5 kilometers total. Okay, so distance would be therefore 60 kilometers, whereas displacement is how far it's traveled from that particular point, despite going that windy direction. Okay, so that would be 10 kilometers plus 20 kilometers, 30 kilometers from that particular point is how far Grandma's house is in terms of displacement as opposed to distance. Okay, the shortest route. So in terms of defining your plus and minus directions, okay, as we move forward, or to the right in this particular example, it's a positive direction, and as you move away to the left, it's a negative direction. That becomes more important when you consider concepts like explosions, where objects go in opposite directions. And for the idea of the y-axis as opposed to the x-axis, in the y-axis, as you go up, it will be positive, and as you go down, it will be negative, which will become more important when we look at projectile motion and the effect of gravity. So in terms of the mathematics, by adding vectors, okay, for this you will use trigonometry. Okay, so when you're adding vectors like this, it's going to be 3 meters per second up, that's why the arrow is pointing, going to be 4 meters per second to the right. So when you add them, the sum of those two will essentially be the hypotenuse of a right-angled triangle. It's important to note too when writing vectors or drawing vectors that the two variables, in this case 3 and 4, go head to tail, and the sum will go head to head to give the sum of 5 meters per second in 2 dimensions. In terms of subtracting vectors, you can clearly see that you've got 3 meters per second minus 4 meters per second. So what you do with that is that you change the direction of the 4 meters per second, okay, and then draw the arrow in the other direction, okay, so it becomes a negative, and you again use trigonometry, finding the sum, and nose to nose, you will, or head to head, as it were, you will see that it is still 5 meters per second, but in the opposite direction. So vectors can essentially be added in any order. Okay, so there are 2 possible ways you could add those 2 vectors there, and the sum is still the same, which is quite reassuring. In terms of calculating a resultant vector, what you'd have to do here is, because the 7 meter and 5 meter vector are traveling in the same direction, you can add them together, which would be 12 meters in total. And then we have it moving also 9 meters to the right. So again, you use trigonometry. So it'll be 12 9 and 15 is the sum again. So it's also important to remember the concepts of SOHCAHTOA to work out angles potentially, because remember, a vector has both a size or magnitude, but also a component of direction. So you usually use that component as a principle of, well, it's going to be a certain number of degrees northwest or southwest, or depending on where the resultant vector is. Okay, so for this particular case, it would be northeast. Okay, and sine theta will be 3 over 5. So theta will be the inverse sine of 3 over 5, or 36.9 degrees. 36.9 degrees northeast. That will be the correct answer for the vector. In terms of vector components, here's an example here. So all vectors can be broken down into the x and y components. Okay, so you have the sum of the x and y components is 13 meters per second. So to work out the x and y components, we use a bit of trigonometry. So the sine of 22.62 will equal y over 13. So if we rearrange that, y will become 13 times the sine of 22.62. So that would give it as 5 meters per second. And conversely, for the x component, it'll be this time the cos of 22.62, okay, which will be x over 13, remembering our SOHCAHTOA. And that means x will be 13 cos 22.62, or 12 meters per second. Just to kind of reinforce that, that's where trigonometry can be your friend. So in this particular case, AH will be A cos theta of the angle, and the y value will be A sine theta. So remember to incorporate trigonometry into your calculations, and if you're unfamiliar with that, brush up on your trigonometry, your SOHCAHTOA.